Okay, so that first part was long. These next two are going to be a little bit shorter, but again, it's important that you understand a lot about these coordinate systems and how they work in ArcGIS. And so that's why we emphasize them. And so in the last part, we just talked about the basics of the GCS, and we talked about how to convert among different forms of the GCS, and we talked about how to use that in ArcMap, or how to find coordinates of a given point on Earth. And so now we're going to talk just a little bit more about the details of the GCS. All right. And so again, latitude, longitude is called the Geographic Coordinate System, or GCS, and it is the basis for all GIS data. All right. Now, it turns out there actually are many different geographic coordinate systems. There's not one. And what do I mean by that? Well, they all work the same way. They all describe an angle for the latitude and an angle for the longitude. So they all use the latitude, longitude in the same way. The reason that there are so many different ones is because they're based upon different spheroids and datums. And the spheroid and the datum are used to model the shape of the Earth. And so the idea is that we start by assuming the Earth is a perfect sphere. But in reality, it is not. It's a spheroid, which is a sphere that's flattened top to bottom. And the reason this happens is because the Earth rotates. And as it rotates, the centripetal force pulls the equator out, and it bulges at the equator. So if it's like you took a ball and you pushed on the top and bottom, it would be sphere-like, but it would be bulging at the middle. That's what the Earth really does. Consequently, when you're figuring out those angles for the latitude, longitude, you have to take this into account, that it's not a perfect circle. And there are different ways of doing that, and it depends upon what you're trying to, basically I think a lot of it has to do with where you're trying to get your coordinates. And so that's why there are different geographic coordinate systems, because they have different spheroids and datums. And so we're not going to get into the math behind these, or why one is better than the other. You just need to understand what these terms mean and why they are used. And so here's a figure from your book again, and this gives you an idea. It's not super clear on this one. If you look in your book, I think the picture's a little bit better, but you get the idea of a perfect sphere versus a spheroid. The spheroid is more realistic. Okay, and then the datum. So the spheroid is defined by, a mathematical model, and then the datum is used to fit a particular spheroid to a particular area because of their different elevations. The two together make your coordinates more accurate in certain areas, but often less accurate in other areas. Again, we're not going to talk about the details behind these, because I'll be honest with you, I don't know the details behind them, but it's not really important for us, especially since we're biologists. We don't really need to know all the gory details behind these. We need to know what they mean and why it's important to understand the different terms, and why we need, what we need to pay attention to. That's what I want you to know, that there are certain things you have to pay attention to. Now, the most common datums that you are going to run into are the NAD 83, the WGS 84, and the NAD 27. The NAD stands for North American Datum, and the one was done in 1927, and then the other one was done in 1983. That's where the numbers come from. The WGS stands for the World Geodetic System, which was done in 1984. These are not the only ones. And you'll notice that a couple of these are North Americans. If you were somewhere else on the planet, you would have something completely different. But for us, working in the United States, most of the time, these are the datums you're going to run into. So when you see these terms, you know what they are. Now, the NAD 83 and the WGS84 are essentially the same when it comes to mapping. And so if you are setting up ArcMap or setting up a new shapefile or whatever, if you chose either one of those, they're going to map about the same. All right. What's the difference between them? The WGS is not really just a datum, it's a system. It involves several other different aspects. And the WGS is appropriate not just for North America, it's appropriate for the entire world for the most part, I think. The big difference here that I've noticed, the WGS84 is most commonly associated with GPS units. And so usually when you have a GPS, if somebody gives GPS coordinates, it's giving you a latitude and longitude, but remember, there are different geographic coordinate systems that give you that latitude longitude. And so which system are you using to define your latitude longitude? Most of the time when you have a GPS, it's using the WGS84. A lot of GPS units you can change and use a different datum, but you often don't want to. When you're working with GPS, usually you can assume it's using the WGS84 geodetic system to calculate its latitude and longitude, and that's pretty accurate. That gives you pretty accurate coordinates. Okay. Well, why do we have different datums? Several different reasons. The first is new technology, right? You've got the NAD 27, which was done in 1927. Well, by 1983, we've got new technology. You've got satellites that can measure the Earth. And so you can come up with a better datum, which again is just kind of a mathematical model. You can come up with one that's more precise and more accurate because you have better technology. And so I think that's why they came up with a new one, right? And so as technology and as our measurements get better and better, you have the need for defining new datums. But you still got tons of data out there that was created using the old datum, and it's not worth going out and updating it. So that's why you kind of have two different systems. Another reason you have different systems, again, the datum helps the spheroid fit to a particular area on the Earth. And so you've got, for example, the North American datum 83 works very well, and it gives us really good, accurate coordinates here in North America. But probably if you were in South America, if you're in Australia, your accuracy would go way down. And so the trade-off is, you know, good coordinates here, it doesn't work very well somewhere else on the planet. Well, you know, you're not going there anytime soon. And if you go to Australia, you just use a different system, okay? So that's the idea behind different datums. And so that's really it. That's all I have to talk about on this particular part. Is now you understand a little bit more of the details behind the GCS. The most important thing is if you're using the GCS, you also have to know which datum you're using to get those latitude and longitude coordinates. Because if you use the wrong datum when you put it into ArcMap, then things are going to map in the wrong place, and things aren't going to line up as well. That's why this is important. So that's all I have right now, and we'll be back with part 3 in just a little bit.